next thing we're going to cover is what's called the celestial sphere. To figure out what we see in the sky and why we see it and where we see it, we have to understand how everything looks and why it moves and why it changes. So the ancients came up with this idea, bring in here, of what's called a celestial sphere. This is our celestial sphere here. And what they imagined was, when they went outside at night, they would look at the stars, and all the stars would appear to move together around the Earth. And it didn't feel like the Earth was moving, so it felt like the Earth was here. And so the whole sky would rotate around. And so to them it seemed like it was this perfect crystalline sphere up in the sky, and embedded on it were the stars, and the whole thing rotated around. So it's a giant ball surrounding the Earth, which rotates around, and it takes 1 day or 24 hours to rotate around once. That is the concept of the celestial sphere. We still use this concept today because it helps us to understand what's going on. So you conceptualize the whole sky as a sphere. And embedded in this sphere are the stars, because all the stars move together. All the constellations don't change shapes. And they're all pretty much the same, especially in the lifetime of a human. Now we know that's not true at all. All the stars are moving. They're all moving in different directions. If you came back millions of years from now, you wouldn't see the constellations you see now. Things change. But for a short lifetime, the lifetime of a human, then you're not going to notice any significant change. The idea of the celestial sphere helps us to understand what we see at night and why we see it. Okay? So, that's the concept of celestial sphere. Just remember, the Earth is inside the celestial sphere and it completely surrounds us. So here is our celestial sphere. And I'm going to put the Earth, whoa, I missed the center though. Put the Earth inside the celestial sphere. How do we figure out our location on the Earth? Well, we figure out our location on the Earth relative to some reference points. Now the Earth is a ball. And they knew it was a ball, so we got to say, okay, if you're trying to find a position on a sphere, a ball, you have to like mark it and say, oh, we're going to count from a specific point. Because otherwise, you spin around, it looks the same from every single position. So what we do on the Earth is we use the axis of rotation of the Earth. So here's the Earth spinning around. Okay? And it's out there in space rotating, but notice it rotates around the north and south poles, or what we call the rotation axis of the Earth. Those points are fixed because the Earth's rotation will keep that point always the same. Now our continents and things can change on the Earth, but the Earth's rotation is always going to be around those rotation axes, that point. Okay, so that's not going to change. So as it rotates around, like this, and notice, first of all, that when it spins, we need to know, does it spin this way or does it spin this way? Is there any way we can think about this and figure it out? Or I should look at it this way. If you're looking at it here, here's the United States. Does the Earth spin this way or this way? So if we have north of, does it spin to the east or does it spin to the west? To think about this, to figure this out, we just have to think about, well, what direction does the sun rise and the moon rise and all the stars rise? All of them rise in the east and set in the west. We know that the reason they're rising in the east and setting in the west is because that's the direction the Earth is spinning. So the Earth is actually rotating towards the east. It spins to the east. Or, if you're looking at it from the top, it spins counterclockwise. Okay, so it's spinning counterclockwise. Which comes back to the question, who defined the way a clock goes? Why is clockwise this direction and counterclockwise the other direction? That goes back to when they first started making mechanical clocks. This was like the 1600s. Before that, how did you tell time? You used sundials. And you would watch the shadow as the sun moved across, the shadow would go in a clockwise direction. And so when they made clocks and they made the hour hand, they wanted the hour hand to mimic the shadow of the sun going around. And so that's the reason that direction became clockwise instead of counterclockwise. All right, so on the Earth, we define our position on the Earth by latitude and longitude. Latitude is how far you are north or south of the equator. Okay? And that goes from 90 degrees north to 90 degrees south, where the equator is at 0 degrees. So on our Earth in here, stay with me here, 0 degrees is here, 90 degrees north is up here, and 90 degrees south is down here. And that measures your latitude, how far you are from the equator on the Earth. For Commerce, Texas, we have a latitude of 33 degrees north. Approximately. It's 33.2 or something, but we're going to round it to 33 degrees. So 33 degrees north, what's that tell us? That tells us that if I make an angle of 33 degrees from the equator, I go up, this is where Commerce is. Or this is going to be my astronomer, we're going to call him Herb. So Herb lives in Commerce. He's 33 degrees from the North Pole. Okay? Or from the equator, I mean, about 1/3 of the distance to the North Pole from the equator. All right, latitude for astronomers is the most important thing because everybody on the Earth at that same latitude sees the exact same stars and they see the exact same sky. So if you go here, latitude 33 degrees puts us right here in Commerce, Texas. But if you scroll all the way across to here, guess what? You hit Kyoto, Japan. It's also at 33 degrees north. They see the exact same sky and stars and everything we do. They just see it 14 hours earlier. So it's all about time when you talk about longitude. All right, so longitude is how far east or west of the prime meridian. And that goes from 180 degrees east to 180 degrees west. All right, what's the prime meridian? The prime meridian is over here. As they realize, you measure from the equator, which is defined by where the poles are, right? It's halfway between them, get you the equator, and then latitude is measured from that point. But to measure how far you are around the Earth, east or west, we have to make a line. And you can imagine if the Earth is spinning around like this, and you're going to like count how many times it's spinning, you have to draw a line and say, okay, we count how many times that line hits. And so they had to figure out where to put this line. And it's every country, when they were doing their own exploration, especially back in the 14, 15, 1600s, when there was a lot of exploration going on in the 17, 1800s, finding out about the Earth, they would take a reference point. And remember, I told you longitude is really about time. And so especially for England, when the ships that would go sail all over the Earth would leave England, they would set a clock to England time, or what we specifically call Greenwich time, which is a suburb of England. Then the ships would keep that clock running the whole time they were gone, even for years. And they would always know what time it was in London. If they knew what time it was in London, then they could say, oh, well, I'm over here in some island in the Pacific. If I just compare what time it is at this island, using the sun or the stars, to what time it is in England, I can figure out how far east or west I am of England. Because once around would be 24 hours. So if I'm exactly half off, I'd be halfway around, or 180 degrees from England. Okay? And the French, they have their own line. The French meridian goes right through Paris. And when they got together in the late 1800s, they decided that they needed an international reference, everybody to use the same line. And so they had a conference and they argued about it, and the British won, and that's why the prime meridian, the one that the whole Earth uses, is the one that goes through London. Okay? Didn't make the French very happy, but that's the way it goes. The reason for that is the British had done more exploration than any other country, and they had all these islands and stuff out here in the Pacific charted to the longitude and latitude from Greenwich, England, and it was easier just to use their system than to use somebody else's system. So that's why we still measure all our longitudes from the prime meridian or from England. For Commerce, Texas, the longitude here is approximately 95 degrees west. So we're just over a quarter of a way around from England to get to Commerce, Texas. All right? All right, so that's what latitude and longitude are. Now, keep that in mind because we're going to translate that to our celestial sphere. Because we have our sphere with all the stars on it, but we have to figure out our coordinates on the celestial sphere as well. And so when we figure out our coordinates on the celestial sphere, we want to use the same coordinate system. So straight above the north pole of the Earth, we have what's called the north celestial pole. And straight above the south pole of the Earth, you have the south celestial pole. And straight above the equator of the Earth, you have the celestial equator.